To accommodate a world that continues to decentralize and decarbonize the electric grid, both prosumers and grid operators will require a system to access and manage the flexibility of resources that reside at the edge of the grid. Near real-time visibility and control of the grid and DERs will be critical to supporting a world to accommodate growth of both electricity demand and generation at our homes, commercial, and industrial facilities. Traditional demand response programs continue to provide system-level benefits and protection. Standard cloud-based DERMS deployments can extend to more flexible resources like PV solar, batteries, and electric vehicles, extracting grid services not available with traditional binary demand response event dispatch. Advanced grid intelligence is now being deployed to capitalize on edge compute, which is baked into the electric meter and data access points, enabling local, autonomous load following that directly resolve customers' electric challenges at its root. As the grid continues to meet the challenges of decarbonization, electrification, and renewables integration, the promise of grid edge intelligence is being realized today to expand into ubiquity tomorrow. As DERs land on our electric systems, with or without notice, it's important to leverage existing advanced meter infrastructure to provide the visibility and control grid operators need to cost-effectively support the evolution of the grid. There's also a large opportunity for the empowered consumer to enable the flexibility of energy resources to meet the growing energy demands of tomorrow. So as we decentralize the grid, it's going to be really important that we provide visibility at the edge, that we have the ability to control assets that are at the edge, and to effectively optimize the network, the low voltage network that's sitting there at the edge. And as we do that, I think it's going to be very important to honor and build a bridge between the grid operators that we have that traditionally are holding the throttle, so to speak, on all the generation that has gone downstream. But now we're opening up the paradigm to include customers that are sitting there at the edge, which also have control and the ability to generate a rooftop solar as an example, consume more electricity through electric vehicles as an example, and to be able to have a two-way bridge so that way we can manage both generation and demand on both sides of the equation. Paramount are the customer success metrics of reliability, resilience, meaning that we have the ability to restore power once it's been off, and then affordability is going to be really important for the energy transition. So we need to move forward in that way. Grid edge DERMS is really going to be fundamental to be able to make this happen by way of having distributed energy resource management systems that can use grid edge intelligence. And that really provides the ability to see things that the grid operators historically have not been able to see before. Itron's IntelliFlex DERMS is unique in that we have a modular approach in addition to being a hybrid approach where we're actually able to have a global cloud optimization, which is pretty standard for typical DERMS in the market, but also to have this very micro local DERMS that's happening at the same time. And the combination of the two is really helpful to accelerate time to value. The hybrid world is really important because we have the ability to still honor that system level down, recognizing big operations issues, but we also now have the autonomous load management from the bottom to do both. Historically, it's always been top-down for the past 30 years with demand response, demand flexibility. But now with autonomous load management, distributed intelligence, and grid edge intelligence, we can also go from the bottom up to meet in the middle. The most interesting regions would be where we have these high pocket densities of DER adoption, and then that accelerates a lot of issues that we have with the grid. So Australia is a really good example of this particular country has PV hosting capacity challenges, and if you look at a grid operator's map, you'll see a lot of red lines, and there's a lot of thermal and voltage violations, and DERMS is being called in now to help manage that as a backstop, so that way we don't have to turn on stadium lights in the middle of the day to burn off all the solar power that can't be distributed backwards through the transformer anymore. The United States, San Francisco Bay Area is a great example of too many EVs adopting at the wrong time, in the wrong place, in really dense pockets. And so what we're trying to do here is protect and honor the transformer and the grid assets, to take a 40-year asset and really allow it to run its life, and not to run through this old utility paradigm, which we call fix on fail. When it burns up or when it smokes or when it blows, we'll have to do a replacement. That's a very reactive way, and moving in the future, we have the ability to proactively monitor and move towards there.